Hi guys, welcome to another video. This is for Functional Skills Level 2 Area and Perimeter. If you're part of my class, you can download these from Google Classroom, or if you're not part of my class, you can download these from the link below. As always, I'd appreciate if you can support my channel. Don't forget to hit the like button and subscribe if you haven't done so. Let's jump straight into it. So hopefully by the end of the lesson, you guys will be able to solve area and perimeter of 2D shapes, including squares, rectangles and triangles. Find the circumference and area of circles, and also work out area and perimeter problems involving compound shapes as well. So just a bit of a recap, this is from level 1. Hopefully you know how to work out the area and perimeter of squares and rectangles. And the new one, obviously for level 2, are triangles, which don't appear in level 1. So for me, squares, obviously area is length times width, and for the perimeter, let's just say add up all the sides. Let's not complicate things, and in fact for all of these, add up all the sides, and same for the triangle as well. Yeah, add up all the sides. And obviously for rectangles as well, that's going to be the same length times width as well. Okay, so for triangles, it's very similar to a rectangle, but obviously if you think of a triangle is half of a rectangle, so same as before, length times width, or in this case base times by height, and we have to halve it to get half a rectangle, which gives you a triangle. Yeah, and that's how you work out area of a triangle. So yeah, don't forget to halve it, otherwise you won't get a triangle, you will actually get a full rectangle if you just do base times height. So yeah, a lot of people do tend to forget to halve it. So just be careful. Well, let's have a look at some examples. Example 1a, work out the area and the perimeter of the following. So you've got a square, rectangle and an isosceles triangle. If you pause the video and try it yourself, feel free to do that, or if not, just feel free to carry on, and I will go through the answers right now. So for the square, let's do the area first, and hopefully you know for a square all the sides are going to be the same. So if that's 6 centimeters, that's going to be 6 centimeters there as well. Same here and same here. And for area, we have to do just one length times by one width, so that's just 6 times 6, which gives you 36. And then we're using centimeters, so this will be centimeters squared. And then for the perimeter, you could just add them all up, so 6 plus 6 plus 6 plus 6, which gives you 6 times 4, which is 24. And that's going to be just centimeters on its own, because obviously perimeter is to do with the length of the outside. So that's that one done. Well, let's do the red rectangle in the middle. Oh, just be careful with this one. This one is in centimeters here, but you've got millimeters for this side here. So you could actually choose which one to change them to. So you could choose millimeters for both. So if I change that to millimeters, that is times that by 10, because there's 10 millimeters in a centimeter. That's going to give me 75 millimeters. Or if you want to change the millimeters to centimeters, divide by 10, that gives you 2.5 centimeters. So let's do area first, which is length times width. Let's assume that you're using the centimeters, so I'll do 7.5 times 2.5. Let's do that on the calculator. 7.5 times 2.5 gives me 18.75 centimeters squared. Or if you did it in millimeters, obviously that's 75 times 25, which gives you 1,000 1,875 millimeters. Sorry, that should be millimeters squared. Yep. So can you see the difference in the obviously the decimal point is in the wrong is in different places for both of them. So just be careful. Depending on which one you used, just give one answer obviously. So if you gave your answer centimeters squared, it's 18.75, or as millimeters squared, 1,875 millimeters squared. Same for the perimeter. You can choose either centimeters or millimeters. Let's do the centimeters first. So 7.5 plus 2.5 plus 7.5 plus 2.5. That gives us exactly 20 centimeters. Or if you did it in millimeters, that will give us 75 plus 25 times by 2, 200 millimeters. Yep, and there's your two answers. Obviously you guys just give the one. For the green triangle, just be careful with this one. This is a isosceles triangle, so two sides are going to be the same. Hopefully you know that. So this is 7.5 on this side. This here must be 7.5 as well. I'm going to put that here. So just be careful. And the vertical height is 7 centimeters, so different to the 7.5 here. So just be careful, they are two different things. Obviously the 7 is the vertical height, which is perpendicular to the base, so obviously it's 90 degrees to the base. This slanted one obviously is the same as that slanted one there. Let's do the area first. Base times height divided by 2. So the base is fine, that's 3.5. Which height do we use? So it's the vertical height in this case, which is the 7 centimeters. So just be careful, don't use the 7.5. I'm going to have to halve it. It's 3.5 times 7 divided by 2 gives me 12.25 centimeter squared. For the perimeter, again, just be careful. Remember we said perimeter is where you add up all the sides. So you're going to have to add 3.5 plus 7.5 for that side there, plus 7.5 for the other side. So in this case, we're not using the 7 centimeters, obviously the vertical height, we're not including that at all. It's just the 3.5 plus 7.5 plus 7.5, which gives us a total of 18.5. Let me just move the screen down a little bit. 18.5. That's going to be centimeters. Yep, so there's your answers. And we didn't have to change anything for that one because they were all in centimeters anyway. Hopefully you guys got the same answers, and if you didn't, hopefully it made sense why. Just be careful, especially with that triangle. Let's have a look at the next section. So another recap from level 1 really, to do with a compound shape where you've got two rectangles stuck together, or sometimes we call it an L shape. It says work out the area of this office. You have a £750 budget to spend on flooring. Work out which flooring you can afford. So it says real oak £21.99 per metre squared, or cherry wood £19.99 per metre squared. Okay, so we're going to have to split the shape. That's one way of doing it. You could do it another way where you can complete the rectangle and work out the missing piece. I'm going to do it this way. Let's call that shape A. Let's call that shape B. So area A, and it's obviously to do with area, hopefully you notice, because it's obviously to do with meters squared, and they're going to cover the floor, obviously, so that's inside all of this. So area A, obviously that's length times width. That's going to be 5 along the bottom, and we're going to need this one here which is 3 plus 3, which is 6 meters there. So 5 times 6 gives me 30 meters squared. And then for area B, again that's length times width. I'm going to need this length here. I already have the height. So this length here is going to be 7 take away 5, which is 2 meters across. So that's 2 times 3, which gives me 6 meters squared. So the total area of the whole shape is, add the two areas together, you get 36 meters squared. Yep, so however you did the area, you should get 36 meters squared, sorry. You know, there are other ways. You could have split it this way as well across. There are quite a few ways of working that out. And now we can work out how much flooring we can afford. So they said real oak cost £21.99 per meter squared. So for every meter squared of flooring, it's going to cost £21.99. Well, we've got 36 meters squared, so real oak is going to cost 36 times £21.99. Let's do that on the calculator. 36 times £21.99. Oh, that's going to cost £791 and 64 pence. Let's check what was the budget. You have a budget of £750, so that's too much, unfortunately. So let's check the other one, which was cherry wood. 36 times, how much was that one? £19.99. It's definitely going to be cherry wood, but we do have to show this. So 36 times 19.99 gives you, yeah, that's much better, £719 and 64 pence. So the only one we can afford in this case is cherry wood. Yep, there's your 3 marks. So this is a bit of a recap from level 1. Hopefully you guys got the same answer. Let's have a look at a level 2 type question then. So this is work out the area of the shape, and obviously this is a compound shape again. So it's like a rectangle with a triangle stuck on the top. So we're going to have to split the shape this way. Let's call this shape A. Let's call this shape B. So area A, which is a rectangle, length times width. That's going to be 12 times 5, which gives us 60 centimeters squared. And then area B, remember for a triangle we need base times height divided by 2. So I'm going to need the base here, that length from there to there, which is 12 take away 7 gives me 5 centimeters for the base. And I'm going to need the height of the triangle as well, which is from here to here. So that is 9 take away 5, which is 4 centimeters. So now we can do 5 times by 4 and halve it. That gives me 20 divided by 2, which is 10 centimeters squared. So total area 60 plus the 10 gives me 70 centimeters squared. Yep, and there's your answer. Put it on the dotted line. So if you guys want to try the next ones yourself, give it a go. Practice question 1A, 1B and 1C. Pause the video, have a go. Obviously you can use your calculators, and when you're ready just unpause it and we'll go through the answers. Let's have a look at practice question 1A then. Here is a shape made from a rectangle and a triangle. Work out the total area of the shape. So again, I'm going to call that shape A and shape B, so area A, which is a rectangle, I'm going to need length times width. So the length is 15 and the width is 9. So 15 times 9 is 135, and they're using centimeters, so this is centimeters squared. Area B, that's a triangle, so I'm going to need base times height divided by 2. So I'm going to need a base here. 15 take away 7, which is 8. And I'm going to need the height, which is this one here, from there to there. 22 take away 9, which is 13 centimeters there. So I'm going to do 8 times 13 divided by 2. So 8 times 13 divided by 2 is 52 centimeters squared. So the total is 135 plus 52 gives me 187 centimeters squared. Don't forget to put the units on the dotted line as well. If you don't put the units here on the dotted line, you would lose a mark as well, so yeah, just be careful. Usually they do put the units themselves on the dotted line, but if it's not there, then you're gonna have to put that in yourself. Yep, 3 marks for that one. Practice question 1b, the area of the rectangle ABDE is 40 centimeters squared. Work out the area of the triangle BDC. Oh, interesting. So this one, they've actually told us the area of the rectangle, this bit here, write that inside. So the area inside here is 40 centimeters squared. To work out the area of the triangle, I'm going to need this height here, because that's missing. Because we've already got the base. So to work out the height, well, that's the same as that right there, which is missing as well. But we know that the length is 8, so they must have done area of the rectangle, obviously is length times width, so they must have done, to get the 40, they must have done 8 times by something, let's still call that W. To work out that missing something, you could work your way backwards, or think of what multiplied by 8 gives you 40, and obviously it's going to be 5. But to work backwards, you can also do the opposite of multiply, which is divide by 8, and that gives you 5, and that's going to be centimeters for this width here. Yep. That means that height of the triangle is going to be 5 as well. And now we can work out area of the triangle, which is base times height divided by 2. So that's 4.5 times 5, and we'll have to halve our answer. That gives me 4.5 times by 5 divided by 2, 11.25. That's going to be centimeters squared. Yep, and there's your final answer. Yeah, just be careful. So if they tell you the area in the question, you're going to have to work backwards to work out one of the lengths in this case. Yep. Well, let's have a look at 1C. Diagram shows the floor plan of an office. What is the area of the floor? So yeah, you've got a weird shape here. This is actually a trapezium, so you could use the trapezium formula if you know what that is. If not, then you're gonna have to do it the old-fashioned way, where you split the shape. I'm gonna have to split it this way, so you get a rectangle, let's call that shape A, and a very small triangle here, let's call that shape B. Let's do area A first, which is, just be careful, it's 50 times by 40. Don't be tempted to use the 55, that's the whole length. along the bottom, so we're not using that one. 50 times by 40, which gives us exactly 2000. That's going to be meters squared. For area B, again, because it's a triangle, I'm going to need base times height divided by 2. So I'm going to need this little bit here for the base, which is 55, the whole length, take away 40, which leaves me with 15 meters here. And the height is going to be the same as this length here, which is 50 on that side. So 50 is the height of the triangle. So 15 times by 50 and divided by 2. Which gives me 375 meters squared. So the total area, 2000 plus 375. And let's put the answer here, 2375 meters squared. Again, don't forget to put the correct units, otherwise you get marked down for that as well. Yep. And of course, if you use the trapezium formula, you should have got the same answer as well. Let's have a look at the next section. So in this section, we're going to look at circumference and area of circles. And we're going to use two formulas. One is for circumference, or the perimeter of the circle. The circumference is just a fancy word for the perimeter. And obviously we have area of a circle as well, which is to do with the inside. So the two formulas you need to know are C equals pi, and you've got this funny little symbol, which I'll explain in a minute, times by d, which is the diameter in the circle. So there's your circumference formula, and for area we use pi again, r, which is the radius, squared with a little 2 in the corner. So I know a lot of people do use a different one for circumference, which is 2 pi r, which is the same thing, but I'm not going to use 2 pi r because I don't want r in both the formulas. So me personally, I tend to stick to C equals pi d and area equals pi r squared for my two formulas, so that I don't get mixed up. But having said that, people do get mixed up every single time. And an easy way to remember what I tend to use, and they do use this in a lot of schools and other places as well. If you say to yourself, cherry pie's delicious, apple pies are too. And it's a really good way of remembering which one's which. So obviously cherry stands for C, that's for the circumference. Pie is delicious, that is the D. Apple pies are too. So I know it's a little bit silly, but these little silly little things, little phrases do help. You know, it helps me anyway. So hopefully it will help some of you guys as well. So cherry pies delicious, apple pies are too. Yep. So I'm going to write that there. And if I don't say cherry pie's delicious, apple pies are too, even me, I get mixed up sometimes as well. So I just say it to myself all the time. So what is this pi? Pi is, obviously it's a funny little symbol here, and on your exam paper it will say use pi for, in any question, use 3.14 for pi, it says. 3.14. In reality, obviously, it does go on forever. It's 3.14 and it goes on forever. There's quite a few decimal places. Not quite a few. It's quite a lot of decimal places, in fact. But for the purposes of functional skills level 2, if you just use 3.14 for pi, So think of it as just as a number, 3 and a bit in this case. That is actually what pi is. And how does it relate to circles? Well, what you just need to know is someone very clever a long time ago figured out if you multiply the diameter, which is the line that goes all the way through the circle from end to end, and it goes through the center, if you multiply that line, the diameter, with 3 and a bit, let's call it, you will get exactly the length of that outside of that circle. Yeah, and that works for every circle, everywhere. Doesn't matter where it is in the world. You know, if you multiply the diameter by roughly 3.14 or 3 and a bit, you will get the length of the outside or the circumference of that circle. Yeah, and obviously they use that for the area as well, and we have to multiply by the radius times by radius again, or radius squared. Yeah, and if you follow these formulas, it should work every single time. So obviously if you get these formulas mixed up, you're not going to get the right answer. You're not going to get any marks either as well. So just be careful you don't get these formulas mixed up. So if you guys want to try these next questions, give them a go. Pause the video, and when you're ready, unpause it and we'll go through some answers. Let's check some answers then. So practice question 2a, circle has a diameter of 140 centimeters. Work out the circumference of the circle. Give your answer correct to the nearest whole number for 2 marks. So if it's to do with the circumference, as it's mentioned here, we are definitely using Cherry Pies Delicious, and I always write the formula down first because it just helps to remind me what am I going to use. Obviously I'm going to use pi, which is 3.14 as mentioned before, times by the d, which is the diameter, and they said the diameter is 140, and we just type that in our calculators. So 3.14 times by 140 gives me 439.6, and that's going to be in centimeters, just centimeters. But they said give your answer to the nearest whole number, which is the units is here where that 9 is. So there's my cutoff point. This 6 is going to help us decide what happens to the 9. But because it's 5 or more for the 6, the 9 is going to go up to a 10. So you put a 0, carry a 1 to the next one, and then the 3 goes up to a 4. That 4 stays the same. Yep, there's the decimal point. So your answer is going to be 440 centimeters. Don't forget the centimeters here on the answer line as well. And that's going to be to the nearest whole number for your answer. Practice question 2b, the radius of the circle is 3.60 meters. Work out the area of the circle. Give your answer correct to 2 decimal places. Okay, for 3 marks. And because it mentioned area, we are using apple pies R2. So that's 3.14 times by the radius. Well, they said the radius was 3.60. You can put the 0 if you wish. You don't have to, because obviously it's not going to make a difference in this case. And it's squared. So you're going to need the square button, which looks like, if you've got those fancy calculators, it looks like X with a little box like that. If you don't have these fancy calculators, obviously you can just do 3.60 times by 3.60. Let me just write that down. Like this. And you should still get the same answer. I'm going to use the square button, obviously. It's 3.14 times 3.6 squared. And you should get, let's write the, I'm going to write the whole answer here, 40.6944. Obviously this is not my final answer because they said, give your answer to 2 decimal places. Well, there's my decimal point. The 6 is the first decimal place. The 9 is the second decimal place. There's my cutoff point. Straight after the dotted line, this is going to help us decide what happens to the 9? And obviously because it's less than 5, that stays the same, that stays the same. There's my decimal point, that stays the same, that stays the same. So it's going to be 40.69, and they were using meters, and because it's area, that's going to be meters squared. Yep, so again, if you get the units wrong, you would lose a mark, or if you didn't put the units at all, you know, you would lose a mark, so just be careful. But hopefully you should get 40.69 meters squared for your answer. Practice question 2C, diameter of the circle is 12 centimeters. Work out the area of the circle, give your answer correct to 1 decimal place. So because they're talking about area, that will definitely be apple pies R2. So we're going to use 3.14. They mentioned the diameter, but we need the radius. See, this is why I think it's a good idea to write down the formula first, just to help remind yourself, what do I need? And in this case, we need the radius. Well, if the diameter is 12, radius will be half of 12, which is 6 centimeters. So that's the one we want here in our formula, and we have to square that. Yeah, so just be careful. 3.14 times 6 squared gives us 113.04 on my calculator. They want the answer to 1 decimal place. So there's my decimal point, there's my dotted line. That's going to help us decide. Well, that's going to stay the same because that's less than 5. There's my decimal point, that stays the same, that stays the same, that stays the same. So for your final answer, you're going to have to put 113.0, and you need the 0.0, otherwise your answer will not be to 1 decimal place. If you just put 113 on its own, it wouldn't be to 1 decimal place, and you'd lose a mark for that. And obviously we have to put the units as well, so they're using centimeters, so this will be centimeters squared because it's to do with area. Yep, there's your 3 marks right there. So just be careful with this one, quite a few places where you can trip up here, so definitely use the radius. Definitely make sure you round it to 1 decimal place, and make sure you put the correct units as well. Practice question 2D, the diagram shows the surface of a pond in the shape of a circle. Circle has a radius of 120 centimeters. Yep, we can see that. Mark wants to put 20 fish into the pond. There needs to be a surface area of 1,800 centimeters squared for each fish. Show that the surface of the pond is large enough for Mark to put 20 fish into the pond. So just be careful with this one. You know, it sounds a bit complicated, but basically what they're saying is they're looking at, or we're looking at the top of the pond, so that's the plan view of the pond from the top. And obviously we're only concerned with the surface area. So still to do with area, you know, don't let that put you off. Don't let surface area put you off. Still to do with the area of the circle in this case. So we're definitely using apple pies R2. Let's use 3.14 for pi. The radius of the circle is 120, they mentioned that. And we'll have to square that. So let's type that in the calculator. 3.14 times 120 squared, which gives us 45216 centimeters squared. Okay, now there's a couple of ways you can do this next bit. What you could do is you could either find out what he has. This is what he's got. What does he need? Well, he needs 20 fish. Each fish needs a surface area of, so 20 times 1,800. This will tell us what the 20 fish need. let's do that separately, which is 36000 or 36,000 centimeters squared. That's what he needs, and then you can just compare with what he needs and what he's got. Well, he's got more than enough. Look at that, it's way more than what he needs. So you can say 45216 is greater than 36,000. So yes, definitely he does have enough for 20 fish. That's one way of doing it. You could, let me do it in a different color pen. Once you get to this step here with the area, you could divide that by the area here. So 45216 divided by 1800. This will tell us how many fish he needs. So 45216 divided by 1800. Yeah, again, so that gives you 25.12 fish. Obviously this is what he has, or this is what he's got. This is what he needs. Remember, the 20 fish is what he needs. So yeah, again, he's got more than enough. 25.12 is greater than 20. So yes, he's got more than enough. In fact, he can fit 25 fish on there if you wanted to. So yeah, that's actually another way of doing that one as well. So two different ways. You definitely need to show the 45,216 centimeters squared for the area of the surface of the pond. Let's have a look at the next one. Practice question 2e. Diagram shows two small circles inside a larger circle. The large circle has a radius of 8 centimeters. Each of the two small circles has a diameter of 4 centimeters. Part A says write down the radius of each of the small circles for just one mark. So yeah, hopefully that's straightforward. If the diameter is 4 centimeters, then half of that will be the radius, which is 2 centimeters. Yeah, and you don't even need to show any working out for that. It's just one mark. Just put your answer, which is obvious. Part B says work out the area of the region shown shaded in the diagram. Give your answer correct to 1 decimal place. Okay, so the idea behind it is we're going to have to work out the area of everything, the whole shape inside, minus these two circles that we don't need, the unshaded ones. So we're going to have to work out the area of these unshaded triangles and then take them away from the whole area. And that will leave us with the shaded area. Yes, that's the idea behind it. Well, let's work out the area of the big circle first. So area of big circle gives us, obviously we're using apple pies R2. That's going to be 3.14 times by the radius of the big one is 8 centimeters. So that's 8 squared. So I'm going to need to do 3.14 times 8 squared on the calculator. 200.96 centimeters squared. Okay, well, let's do the area of one of these smaller circles. So area of small, again that's going to be pi r squared, or apple pies r2. 3.14 times the radius of the small, well, that's what we got for the previous answer, which was 2, and we have to square that. So 3.14 times 2 squared gives me 12.56 centimeters squared. So therefore the area of the shaded region gives me, so the whole area 200.96, take away 12.56 sorry, for one of the circles, and you'll have to take away another 12.56 for the other circle. which gives me 200.96, take away 12.56, take away 12.56. You could have doubled it and then take it away. It's absolutely fine. I'll do it this way. 175.84 centimeters squared. Give your answer to one decimal place. So there's my dotted line. So that's going to help us decide. And because that's less than 5, that's going to stay the same. So that's going to be 175.8 centimeters squared. You can put that on the dotted line. Yep, hopefully you got the same answer. You could have done it slightly different to me, but you should get the same answer though. Practice question 2F. Top of the table is a circle. Radius of the top of the table is 50 centimeters. Work out the area of the top of the table. Well, that's just going to be apple pies R2. So 3.14. Radius, they said, is 50. And we have to square that. It's 3.14 times 50 squared. That gives me 78.5. I'll just put my whole answer because they didn't say. That's good enough. Yep, for 2 marks. And then they said the base of the table is a circle. Diameter of the base is 40 centimeters. Work out the circumference of the base. Okay, so if it's circumference, that's cherry pies delicious. So 3.14 times the diameter. What did I say the diameter was? Diameter was 40. So I didn't have to change anything for these. That's pretty good. 3.14 times 40 gives me 125.6. So I didn't have to round anything, didn't have to change anything. This was very straightforward for both of these. Hopefully you got the same answer. Practice question 2G. John has a flower garden in the shape of a circle. Diameter of the garden is 5 meters. John wants to put fencing around the edge of the garden. Fencing costs £1.80 per meter. Work out total cost of the fencing. So first thing you should ask yourself, is it to do with area or perimeter? And hopefully you've noticed fencing is going to go around the edge of the garden. There's your big clue to tell you. Definitely to do with perimeter, or the fancy word for perimeter of a circle is circumference. So we're definitely using cherry pies delicious. So 3.14 times by the diameter. They said the diameter was 5. That gives us 3.14 times 5, which is 15.7, and that's going to be in meters. So that's the length of the outside. Okay, so the fencing costs £1.80 per meter. So there's 2 different answers for this actually, because if you some people might use this as it is, 15.7 meters, and just times it by the £1.80. Or other people might round it and think, you know, you can't really buy 0.7 of a fence. There's not enough information in this question to tell you whether they can cut and join these, or you have to buy the fencing in whole meters. Obviously in real life you probably do buy the fencing in whole meters, but it's not wrong if you did do 15.7 times the £1.80, which gives us £28 and 26 pence. Or what you could do is round it to 16. So imagine that you go into the shop and you're buying a whole number of meters. So you're buying 16 meters times £1.80, which gives us 16 times £1.80, £28 and 80 pence. They would accept either answer because they know some people might use the 15.7, some people might round it to the 16, because in real life you can't buy 0.7 of a fencing. So yeah, it does make sense why some people would use 16 instead. Yep, so that's 2 possible answers for that question. Last question before I show you guys the next video, which is the more difficult circle questions. This one's actually quite difficult as well, actually. Practice question 2H. Diagram shows a CD. CD is a circle of radius 6 centimeters. CDs of this size are cut from rectangular sheets of plastic. Each sheet is 1 meter long and 50 centimeters wide. Work out the greatest number of CDs that can be cut from one rectangular sheet. So this is a interesting question, let's say. And you know, unfortunately you can't do it the traditional way, where you work out the area, because obviously it's to do with area, how many you can fit, or how many you can cut from one sheet or one rectangle. So in fact, they've not drawn the rectangle. Let me draw the rectangle and show you guys what they're talking about. So there's my rectangle, let's say, and they said it's, what did they say, 1 meter long and 50 centimeters wide. Yep. And they're going to cut these CDs out from this sheet of plastic. Okay, and how many CDs can they cut from this sheet of plastic? So unfortunately you can't do the area of the rectangle divided by the area of the circle, because we're not using the whole area inside. Unfortunately, there will be a lot of gaps in here, all these little bits of plastic, you know, in the corners. They're not going to make that into another CD. That's going to go to waste. That's going to go in the bin. So you can't do the whole area divided by the area of the CD, because we're not actually using the whole area. So you're going to have to do this differently to previous questions. Let me show you guys the only way to do this question. Is by thinking of the diameter of the CD, which goes across from end to end. Well, we know the diameter, well, hopefully you know the diameter is going to be double the radius. So if the radius is 6, the diameter is going to be 6 times 2, which is 12. So that's 12 right there from end to end. Now, how many 12s can fit along the top? You're going to have to do 50 divided by 12. Let's do that on the calculator. So 50 divided by 12 gives me 4.16 recurring. There's a little dot there. Think of it as 4 and a bit CDs. Yeah, so if you imagine 4 and a bit CDs like this, it's going to fit along the top there, inside. But obviously you can't have a bit of a CD. So let's call it 4 CDs going this way. Okay. And then do the same going down the plastic sheet. Obviously this was in meters. Let's change that to centimeters. 100 centimeters is 1 meter. And again, you're going to check how many CDs can go this way. And remember that the length from end to end is the same as what we said before, which was 12. So how many 12s go into 100? Let's do that on the calculator. 100 divided by 12 equals 8.3 recurring. So again, 8 and a bit CDs, and again you're going to have to ignore that bit there. So let's call it 8 CDs going this way down. Okay, so that means in total you've got 8 times by 4 CDs, or 8 by 4, which is exactly 32 CDs for your final answer. And if you've got any other answer apart from 32, it would be wrong. So just be careful. Yeah, it has to be 32, can't be any other answer, I'm afraid. And this is the only way you can do this type of question. So if you imagine, or not imagine, you're going to have to figure out if there is any wastage, and in this case there's loads of gaps in this question, you know, you're not going to be using those gaps. You're going to have to do it this way. So any question where you've got gaps in there, I mean, if they fit exactly in there, if this CD was like a, I don't know, let's say a tile, which is rectangular, and then there were no gaps, then yes, you can do it the old-fashioned way, where you work out the areas and do it that way. But if you do have gaps, then you have to do it this way, I'm afraid. Yep, so hopefully that made sense. That's it for this video. In the next part, I'm going to show you guys the more difficult circle questions, if it wasn't difficult enough. So make sure you like this video, make sure you subscribe, and watch out for any notifications for any new videos as well. Thank you guys. I shall see you in the next one.